All right, so we're going to take our next lesson into how to name these hydrocarbons. Before we were given the name, then we would have drawn a picture something like this or this. But now we're going to do the reverse way. And this can be a little bit trickier because there are steps you have to do in order to do it correctly. Um, there are many ways to name a drawing, but there's only one correct way. And I'll explain why the further we get into the lesson. But if you follow these four simple steps, you're going to be able to do this flawlessly. So the first step, no matter what we're dealing with, picture-wise, carbon chain, hydrocarbon-wise, is that we have to identify the longest continuous chain. Now, I like to highlight it. Now, if you don't have a highlighter, you could still circle it or put a line through it. I'm going to show you all the different ways you can do it without a highlighter. But we're going to start simple, and we're going to move to something more complex. And that's just going to kind of help build on the skills. So the first thing we have to do is identify the longest carbon chain. What I mean by that is I simply mean just counting. Where is the longest continuous set of carbons? So in the first picture, I made it really simple because, well, you'll see in a second. If I go straight across the picture, as in this 1, 2, 3, 4, 5, 6, I get a 6-chain carbon. That's my longest continuous chain going that way. I could also start with this carbon and do one. Come on, buddy. Nope. Hold on. Oh, I can hit a pause button. Or if you started from this carbon, you would get the same result of a 6-carbon chain. 1, 2, 3, 4, 5, 6. So either way you do that, for this drawing, you would get a 6-carbon chain as the longest. I want to show you really quickly a bad example of the non-longest carbon chain would be to go from carbon 1, 2 to 3. So incorrectly labeling this as a 3-carbon chain is not the longest continuous carbon chain. Therefore, that would be incorrect. So 6 is the longest way to do it. And it doesn't matter if you go straight across or like that. Once you've identified it, you can highlight it. Now, because I did this one in purple, I'm going to do this. So highlighting can be done with a highlighter. It can be done with a pen, just like I did. Or the way I like to do it if I have a pen is I'll just circle it. And once it's circled, it's out of my hair. I know that all of these carbons are going to be named later on. Now, whatever's left over is going to be a branch. And so this right here, this carbon, which I'm going to put a box around, that's a branch. So we have the longest continuous chain and this one branch coming off. So those are the first steps. Number 1, identify the longest chain. Number 2, almost through number 2, use the smallest possible numbers. So we have to name this and number this. If you recall from last week, there was always a number, which was the address, as well as the type, the descripting branch. So you can number this in 2 ways. And I'm going to write both names down. So this could be written as, this is the first carbon, if we count from this side of the chain to this one. And this one would be the second. So this, labeling, numbering from 1 to 6, this branch would be located on the 1, 2, second carbon. Okay, second carbon going that way. Number 3, we have to name the branch using the prefixes of YL. So back to what we were talking about before. If you notice, there's only 1 carbon in this box. There's only 1 carbon in this branch. I finally printed one of these guys out, although you've all become pretty familiar with it by now. The number of carbons, if it's 1, it gets the meth prefix. Branches end in a YL. So this branch going this way is a methyl branch. So putting all of this together, all of this has to be done before you can actually name it. Counting in this direction would be called 1. 2 is the address of the branch. Branches always come first. Methyl. And then naming the longest continuous chain at the end. 1, 2, 3, 4, 5, 6. Hex. Oh, where'd that go? Oh, there it is. Hex. And because they are all single bonds, it's hexane. 2-methyl hexane. Now, this is the correct way to do it. Some of you may argue, well, if I counted from this side, which you can do, and I'm going to show you in a second when that's the case, this methyl branch that we've already identified, if this was carbon 1, 2, 3, 4, this would then be carbon 5. And you could incorrectly name this as 5-methyl hexane. The key is you always want the number to be the lowest. So my suggestion, if you're unfamiliar or if you're having trouble with this later on, is to number it both ways, write out the names of both ways, and then you can just identify the correct way because it has the lowest number associated with it. So here's an example. Now in the example I already gave you, the numbering has to be going from right to left. And it's also identified the longest chain for us. I can, if you look at it this way, 1, 2, 3, 4, 5, that's not the longest chain. 1, 2, 3, 4, 5, that's not the longest chain. 1, 2, 3, 4, 5, that's not the longest chain. 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. The only way to get the longest chain of carbons in consecutive order is straight across like this. So I'm going to do what I do with a pen and not a highlighter, and I'm just going to circle it. Anything outside of the circle has to be named additionally with the YL branching. So I'm going to put those in boxes so I know however many boxes I have, that's how many branches I have, that's how many names I have to include correctly. So the numbering was written here before, 1, 2, from right to left. And hopefully you're picking this up quickly. Going from this way, the first branch that is encountered is on the second carbon. Now that is the lowest possible number to represent a carbon atom. Because if we went from this side to this side, if this was carbon 1, 2, the first branch would come at the third. So this is a really good example of when you have to check both left to right and right to left. Because there is only, like I said, there's only one correct way to do this. And that is, this is part of those rules, using the lowest number. So step 1, identify the longest chain. Step 2, identify the branches. Step 3, identify the location of the branch that is at the lowest numbered carbon from the end. And then we put it all together by saying this right here is a methyl group. I know it's a methyl group. How do I know it's a methyl group? It's got 1 carbon. This is a methyl branch. How do I know it's a methyl branch? It's got 1 carbon. This, on the other hand, is an ethyl group. Oh, wow. How do I know it's an ethyl group? Oh, gee. Just get my handy dandy. If there are 2 carbons, the prefix is eth. If it is not part of the original longest chain, it's a branch. So it ends in YL. Now at this point, we can put it all together. But we have to remember, we can't just use names, we have to use numbers. So There's no real right way to do this. I'm going to write the 3-ethyl first, though, because it'll give me a chance to explain this next step. Why is it 3? Third carbon, 1, 2, 3, location 3, description of the branch. The next thing is the methyls. So if we were to number this, we would correctly number this as 2 and 4. There is a methyl group at 2 and 4. 2,4-methyl. But if you remember from the videos last week when we were talking about going from a name to a picture, there was this silly little di thing in there, which was redundant. And so it, instead of it being 2,4-methyl, it's 2,4-dimethyl. Honestly, the Regents doesn't mess with the dimethyls anymore because they try and keep it much simpler. You know, more like a question like this than this. But as you know, the more difficult we make it on ourselves now, the easier it is later. So 3-ethyl, 2,4-dimethyl, and then we're not done. We have to name the whole chain. So the whole chain had 1, 2, 3, 4, 5, 6 carbons. 6 carbons all connected by a single bond. And so we are dealing with a hexane backbone. So if you know, and one good way to do this is you could take the name that you drew or that you came up with, and you can draw it. So you could check to see if your drawing matches that drawing. You know, recap, hexane was a 6-carbon branch. So 6 carbons. Bah, 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 bah. On the third carbon, there was an ethyl. 1, 2, 3, ethyl. At the second and the fourth, there were a methyl. 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 And so 3-ethyl, 2,4-dimethyl. Hexane is how you would come up with the name for this. Let's try these two here. Now, the H's are not on these pictures just because there's a lot going on, and I thought it would be better to just eliminate them for the moment. So I'm going to stop this video to start a new one in a